When you press play on a movie or sync photos across devices, it feels like magic. But it's really the cloud at work. This invisible network powers everything from streaming your favorite shows to collaborating on documents worldwide. Instead of carrying hard drives or installing software with disks, the cloud gives you instant access and convenience. Massive data centers, real buildings packed with servers, store and process your data, making it available anywhere, anytime. Every time you post a picture, play a game online, or check the weather, your data travels across the globe in seconds. The cloud is the invisible force connecting and empowering our digital lives. The cloud is simply using powerful computers over the internet instead of your own device. Like plugging into a shared power grid, you tap into a global network of servers for storage, apps, and processing. Before the cloud, you had to install programs and save files locally. Now you access and store everything online. Some servers store data, others run apps, and you rent just what you need when you need it. This on-demand access levels the playing field, letting anyone, from startups to global companies, innovate without huge upfront costs. Cloud computing's flexibility and power have sparked a wave of global innovation. Cloud computing isn't just for tech giants. It's in your pocket, powering your favorite apps. Music, maps, and movies stream from the cloud, not your device, making your phone a gateway to vast online resources. You can start a movie on your TV and finish it on your phone because the content lives in the cloud, not on your devices. For businesses, launching new services is faster and cheaper. No more buying and maintaining physical servers. The cloud powers everything from online shopping to mobile banking and healthcare, transforming how we live and work. It's the invisible utility driving today's digital economy. Understanding the cloud means understanding the engine behind our connected world. As more devices, from fridges to cars, connect online, the cloud handles the massive data they generate. Knowing how the cloud works helps you make smarter choices about your privacy and digital life. Cloud skills are now essential in nearly every career, from marketing to design. The cloud enables instant communication, entertainment, and collaboration, core to modern life. By grasping the cloud, you see the invisible network shaping your world. Imagine the cloud as a digital filing cabinet you can open from anywhere. Instead of saving files to your computer, you store them online. Safe, accessible, and easy to share. But the cloud is more than storage. It's also powerful computers doing work for you, like editing photos or crunching numbers. You use the cloud's processing power, freeing up your own device. It's a universal office, workshop, and library, accessible from any device anywhere. The cloud lets you do more than your device ever could alone. Cloud computing's roots go back to the 1950s, when mainframes were shared by many users. The internet's rise in the 1990s let companies deliver software online, paving the way for today's cloud. The cloud symbolized the complex network behind the scenes. Now it means moving work from your device to powerful servers online. The goal has always been the same: make computing power accessible and efficient for everyone. Advances in internet speed and technology finally made global, on-demand computing possible. Today, the cloud is the reality that brings this vision to life for billions. The turning point for cloud computing arrived in the early 2000s with Amazon. Amazon's engineers became experts at managing huge computing infrastructure. This led to a revolutionary idea: rent out spare computing capacity. In 2006, Amazon launched Amazon Web Services, AWS. They offered services like S3 for data storage, and EC2, renting virtual servers by the hour. Computing was now a utility, like water or electricity. You only paid for what you consumed, making it accessible to anyone with a credit card. This lowered the barrier to entry for innovation. Soon, other tech giants like Google and Microsoft followed, creating a competitive marketplace. The breakthrough was the business model, transforming computing into a service. You might think cloud computing is complex, but you're likely already a heavy user. Email services like Gmail or Outlook are cloud applications. Your emails are stored on massive servers, not your device, and online document collaboration like Google Docs is another example. Multiple people can edit the same document in real time because it lives in the cloud. Streaming services like Netflix and Spotify are also cloud-based. Even online photo storage is a cloud service. Backing up your photos to Google Photos or iCloud protects your memories. The cloud is deeply integrated into our daily digital habits, often seamlessly. We often use the term the cloud as if it were some ethereal, magical place, but it's important to pull back the curtain and remember what it really is. At its core, the phrase "the cloud" is just a friendly way of saying someone else's computer. You are sending data over the internet to a specific physical server, a real computer sitting in a real building somewhere on Earth. That building is what we call a data center, and it's the physical heart of the cloud. These data centers are impressive and secure buildings. They are massive structures filled with tens of thousands of computer servers. Companies like Amazon, Microsoft, and Google have become global computing landlords. You, as a user, are a tenant, renting a portion of their resources. This allows you to benefit from their scale without building your own data center. It's all grounded in physical reality. It's a network of powerful computers connected by fiber optic cables. Understanding this helps demystify the cloud. We've talked about what the cloud is and how it works. Now, let's get into the different ways you can use it. To make this super clear, we're going to use an analogy that everyone loves. Pizza! You have a few different options, right? You could make it from scratch, buy a pre-made kit, or just order a fully cooked pizza. These options are a lot like the main service models in cloud computing: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. It's all about deciding how much of the work you want to do yourself, and how much you want the cloud provider to handle for you. Think of it as a spectrum of control versus convenience. Understanding these three models is the key to understanding how businesses and developers actually use the cloud. So, grab a mental slice of your favorite pizza and let's break down what each of these as a service models really means. Let's start with infrastructure as a service, or IaaS. In our pizza analogy, IaaS is like buying all the raw ingredients to make a pizza at home. The store provides the basic infrastructure, the ingredients, but you are responsible for everything else. That's exactly what IaaS is in the world of computing. A cloud provider gives you the fundamental building blocks of a computer system over the internet, like virtual servers, networking, and data storage. It's like they're giving you a virtual computer, but it's completely empty. It's up to you to install an operating system, your database software, manage security, and run your applications. The cloud provider manages the physical data center, but you manage almost everything on the software side. It's the do-it-yourself option for cloud computing, giving you the most power and control. Who chooses the DIY pizza kit? Who needs the raw control of infrastructure as a service? IaaS is used by IT administrators, systems engineers, and DevOps teams. They need flexibility for custom setups. For example, a bank with a custom financial system can use IaaS to migrate to the cloud without rewriting their software. Startups also love IaaS. Imagine launching a mobile game. Start small, pay little. If it goes viral, scale up instantly. This on-demand scaling is a hallmark of IaaS. IaaS is also key for high-performance computing tasks like scientific simulations. Rent a massive server cluster, then shut it down when finished, paying only for what you used. Now let's move up one level of convenience to our next model: platform as a service, or PaaS. If IaaS was the DIY kit where you buy all the raw ingredients, PaaS is like buying a take-and-bake pizza. With a take-and-bake, the pizza shop has already done some of the work for you. They've made the dough, simmered the sauce, and even put the cheese and toppings on. All you have to do is take it home, pop it in your oven, and manage the baking process. You don't have to worry about the underlying ingredients, but you still control the final cooking. This is exactly what PaaS provides for software developers. The cloud provider gives you not just the raw infrastructure, but also the platform on which you can build and run your applications. This platform includes the operating system, database systems, web servers, and programming language environments. All of that underlying stuff is managed for you by the cloud provider. As a developer, you don't have to worry about updating the operating system or patching the database. You can just focus on what you do best: writing the code for your specific application and deploying it on the platform. Think of it as the perfect middle ground. With IaaS, developers would have to spend a lot of time setting up and managing their servers before they could even start writing code. With PaaS, all of that setup is handled. The developer gets a ready-made environment where they can immediately start building, testing, and launching their software. This dramatically speeds up the development process. It allows teams to create new applications and roll out new features much more quickly because they're not bogged down with managing the complex infrastructure underneath. So, with PaaS, the cloud provider manages the data center, the servers, the storage, the networking, and the operating systems and other platform software. The user, who is typically a software developer, only has to manage their own application code and data. It removes the headache of infrastructure management and provides a streamlined workflow for creating software. It's the ideal choice for developers who want to build and deploy applications quickly without getting into the weeds of server administration. It's all about focusing on the code, not the plumbing. Platform as a service is for software developers and teams. It abstracts away the tedious work of setting up a development environment. A real-world example is Heroku or Google App Engine. A developer can write code and launch it with a simple command. The PaaS provider automatically provisions servers, configures databases, and deploys code. This is powerful for agile teams who want to push out updates quickly. PaaS is also invaluable when multiple teams are collaborating on complex software, providing a standardized platform. PaaS is a great choice for developers who want to experiment with new technologies, lowering the barrier to entry. Finally, we arrive at the most common and widely understood cloud service model, software as a service, or SaaS. In our pizza analogy, this is the simplest option of all. You just pick up the phone or open an app, order a pepperoni pizza, and it arrives at your door hot, fully cooked, and ready to eat. You don't have to worry about the ingredients, the recipe, the oven, or even the dishes. You just consume the final product. The pizza restaurant has handled absolutely everything for you. All you need is a way to access it, in this case your front door. That's precisely what SaaS is. It's software that is delivered over the internet, on a subscription basis. The cloud provider hosts and manages the software application, the underlying infrastructure, and all the maintenance like software updates and security patches. You, the user, don't install anything on your computer. You just access the software through a web browser or a mobile app. Think about the services you use every day: Gmail for email, Netflix for movies, Spotify for music, or Dropbox for file storage. These are all perfect examples of SaaS. You pay a monthly fee, or use a free version with ads, and you get access to a fully functional application. This model is by far the most prevalent for both consumers and businesses. For individuals, it provides instant access to powerful software without any technical hassle. For businesses, it's a game changer. Instead of buying expensive software licenses for every employee and hiring an IT team to install and maintain it on every computer, a company can simply subscribe to a SaaS solution. A great business example is Salesforce, a customer relationship management tool, or Microsoft Office 365. Companies pay a per-user, per-month fee, and their employees can access the tools from anywhere. The key benefit of SaaS is its simplicity and convenience. The user doesn't have to worry about anything technical. How does it work? Where's the data stored? How is it kept secure? That's all the responsibility of the company providing the service. This has made sophisticated software accessible to everyone, from individuals to small businesses that could never have afforded it in the past. It's the ultimate as a service model, where all you need to do is sign up, log in, and start using the product. It's computing, delivered right to your screen, ready to go. Imagine you own a small ice cream shop. What happens when 1,000 people line up outside your door? You're limited by your physical infrastructure. Cloud computing offers scalability, the ability to easily increase or decrease your resources to match demand. You can simply add more computing power, memory, or storage. It's like magically summoning extra ice cream machines when needed. Scaling up is like replacing your small ice cream machine with a bigger one. Scaling out is like adding more machines of the same size. This is elasticity, the ability for the system to automatically grow and shrink based on traffic. Companies never pay for unused resources, and customers get a reliable experience. Before the cloud, starting a tech company meant buying expensive computer hardware. This capital expenditure, or CapEx, was a huge barrier. Cloud computing flips this. Instead of buying, you rent from providers like Amazon, Google, or Microsoft. This shifts costs to a monthly operating expenditure, or OPEX. Like renting an apartment versus buying a building. The cost savings go beyond the initial purchase. The cloud bundles costs, and providers manage at a massive scale, more cheaply than any single company. With the cloud's pay-as-you-go model, you only pay for what you use. This is incredibly efficient, freeing up money to reinvest and grow. A common question people have about the cloud is it secure? Is it safe to put my important information on someone else's computer? It's a fair question, but for the vast majority of users and businesses, the answer is a resounding yes. In fact, major cloud providers can offer a level of security that is far beyond what most companies could ever hope to achieve on their own. Think of it this way. Would you rather keep your life savings under your mattress, or in a vault at a major national bank? The bank has guards, alarms, cameras, and experts dedicated solely to security. It's their entire business. Cloud providers like AWS, Microsoft Azure, and Google Cloud are like those banks for data. They spend billions of dollars every year on securing their infrastructure. Their data centers are physically protected with multiple layers of security, including fences, security guards, biometric scanners, and video surveillance. These are some of the most physically secure buildings on the planet. Gaining unauthorized physical access to the servers where your data is stored is practically impossible. This level of physical protection is something that a typical company could never afford or manage for its own server room. Beyond physical security, these providers employ armies of the world's top cybersecurity experts. Their entire job is to monitor the network for threats, defend against attacks, and constantly update the systems to protect against the latest vulnerabilities. They have developed sophisticated automated tools that can detect and respond to threats in real time. For a business, trying to hire this level of talent and build this kind of security operation would be astronomically expensive. By using the cloud, they get to benefit from this world-class security team as part of the service. Of course, security is a shared responsibility. The cloud provider secures the cloud itself, the hardware, the data centers, the network. But you, the customer, are still responsible for securing what you put in the cloud. This means using strong passwords, managing who has access to your accounts, and configuring your applications securely. The cloud provider gives you all the tools you need to do this, like encryption, firewalls, and identity management services. But it's up to you to use them correctly. When used properly, the cloud provides a security posture that is far stronger and more resilient than a traditional on-premise setup. Imagine the worst has happened to your business. A fire, a flood, or a major power outage has destroyed your office, including the server room where all your company's data and applications are stored. Everything is gone. Your business is at a complete standstill, and it could take weeks or even months to get new equipment and try to restore everything from old backups if you even have them. For many businesses, an event like this would be the end. The ability to recover from a disaster is critical for survival, but building a good disaster recovery plan used to be incredibly complex and expensive. This is where the cloud offers another transformative benefit: simplified and affordable disaster recovery. Cloud providers don't just have one data center, they have dozens of them located all over the world. These are organized into regions and availability zones. An availability zone is one or more data centers in a specific location, and a region is a collection of availability zones in a geographic area, like the US East or Western Europe. This global footprint is the key to incredible resilience. You can design your application to run in multiple locations at the same time. Using the cloud, a company can easily replicate its critical data and applications from its primary data center to another one in a completely different city or country. So, if your main operations are running in a data center in Virginia, you can have a live, up-to-the-minute copy of everything running silently in the background in another data center in Oregon. If a major disaster like a hurricane were to knock the entire Virginia region offline, the cloud platform could automatically redirect all of your users to the Oregon site. Your customers might not even notice anything happen. This level of redundancy used to be a luxury reserved for only the largest global banks and corporations, as it meant building and maintaining two entire identical data centers. The cloud makes this accessible and affordable for everyone. Even a small business can set up a robust backup and disaster recovery plan in a matter of hours for a tiny fraction of the traditional cost. This ability to withstand failures and bounce back quickly from disasters provides a level of business continuity that gives companies and their customers immense peace of mind. It's like having a perfect clone of your entire business, ready to take over at a moment's notice. In the past, work was tied to a physical place. To access your files, your software, and your colleagues, you had to be in the office. Your work computer had all the necessary programs and was connected to the local company network, where the shared files were stored. Working from home or on the road was often difficult or impossible. This created a rigid work environment that was confined to the four walls of an office building. But, the cloud has completely shattered these walls, ushering in a new era of flexibility and collaboration. Because cloud services are accessed over the internet, they are available from anywhere, on any device. This is really the fundamental principle that enables modern remote work. An employee can be at home, in a coffee shop, or on a train and have access to the exact same applications and data as they would in the office. Think about using a SaaS application like Microsoft Office 365 or Google Workspace. You can start writing a report on your desktop computer at work, continue editing it on your laptop at home, and then review it on your phone while waiting for an appointment. Your work is no longer tied to a single machine. This location independence naturally leads to enhanced collaboration. Cloud-based tools are designed from the ground up to allow multiple people to work together seamlessly, regardless of where they are. We've all experienced this with shared documents, where teams can co-edit a presentation or spreadsheet in real time. This extends to project management tools like Trello or Asana, communication platforms like Slack or Microsoft Teams, and design software like Figma. The cloud becomes the central hub, the shared digital workspace where the team comes together to create, communicate, and move projects forward. This flexibility has had a profound impact on how companies operate and how people think about their careers. It allows businesses to hire the best talent from anywhere in the world, not just from the city where their office is located. It provides employees with a better work-life balance, cutting down on commute times and allowing for more flexible schedules. The cloud provides the technological foundation for a more distributed, agile, and human-centric way of working. It connects us not by physical proximity, but by shared access to the information and tools we need to do our best work together. We've explored cloud services like IaaS, PaaS, and SaaS. Now let's discuss where these services live. Cloud deployment models determine infrastructure ownership and location. The main models are public, private, and hybrid cloud. Choosing the right model is a huge decision depending on specific needs. Public cloud is like a bus, affordable and shared. Private cloud is like owning a car, complete control, but you handle everything. Hybrid cloud is like using a car for commuting and a bus for long trips. These models define a company's relationship with its resources, answering questions about ownership, location, and control. Let's start with the public cloud. This is the model we've mostly been talking about so far. The public cloud is owned and operated by a third-party cloud provider like Amazon Web Services, Microsoft Azure, or Google Cloud Platform. They own the massive data centers, manage all the hardware and networking, and deliver computing resources over the public internet. The public cloud is like the city bus system. You share the underlying hardware with other customers, but your data is secured. The biggest advantages are its massive scale and pay-as-you-go cost structure. This model also provides incredible elasticity and scalability. Companies like Netflix are a prime example of a business built entirely on the public cloud. The public cloud provides the speed, agility, and cost-effectiveness they need to compete. Now let's look at the opposite end of the spectrum, the private cloud. As the name suggests, a private cloud is a cloud computing environment that is dedicated to a single organization. The hardware and infrastructure are not shared with any other customers. It's a completely isolated and private environment. In our transportation analogy, this is your own personal car. You own it, you control who gets in, you decide where it goes, and you are responsible for maintaining it. It offers the highest degree of control and privacy, but it also comes with more responsibility and cost. There are two main ways to set up a private cloud. The first is an on-premises private cloud. This is where a company buys all of its own server hardware and builds its own data center right in its own facility. They manage everything themselves, but they use cloud technologies like virtualization and automation to make their infrastructure more efficient and agile, just like a public cloud. The second option is a hosted private cloud, where a company rents an entire section of a third-party data center for their exclusive use. The hardware is dedicated to them, but someone else manages the physical building. So why would a company choose this model when the public cloud is so cheap and scalable? The primary reasons are security and regulatory compliance. Some organizations like banks, hospitals, or government agencies handle extremely sensitive data. They might have strict legal or regulatory requirements that dictate where their data can be stored and who can access it. A private cloud gives them complete control over their environment, allowing them to implement custom security measures and guarantee that their data never leaves their site. This level of control is essential for meeting their compliance obligations. For these organizations, the trade-off is worth it. They might pay more and lose some of the massive scalability of the public cloud, but they gain peace of mind and total control. They can build a computing environment that is perfectly tailored to their unique security and operational needs. A large financial institution, for example, might use a private cloud to run its core banking systems, ensuring that sensitive customer transaction data is kept in the most secure and isolated environment possible. For them, the enhanced security and control of the private cloud are not just a benefit, they are an absolute necessity. As you might have guessed, most large organizations don't operate exclusively in one model. The reality for many businesses is somewhere in the middle. This brings us to our third model, the hybrid cloud. A hybrid cloud is an approach that combines a private cloud with one or more public cloud services, with technology that allows data and applications to be shared between them. It's a best of both worlds strategy. It allows companies to keep their most sensitive data in a secure private cloud while taking advantage of the powerful, low-cost resources of the public cloud for other tasks. Think back to our transportation analogy. The hybrid cloud is like owning your own car for daily errands and commuting, your private cloud, but using the public bus system, the public cloud. When you need to go to a big event downtown to avoid the hassle of traffic and parking, you use the right tool for the job. In the tech world, a company might use its private cloud to host its core customer database and internal financial systems, the crown jewels that need maximum security. But they might use the public cloud to host their public-facing website, which needs to scale up to handle lots of traffic. This model provides tremendous flexibility. A common use case is called cloud bursting. A company runs its day-to-day operations in its private cloud. But what happens if they experience a sudden, unexpected spike in demand, like a retailer during a flash sale? With cloud bursting, the application can be configured to burst out into the public cloud, automatically using public cloud resources to handle the extra load. Once the spike is over, the application scales back down to just the private cloud. This way, the company doesn't have to overbuild its private cloud just for those rare peak moments. The hybrid cloud has become the dominant strategy for most large enterprises. It acknowledges that a one-size-fits-all approach doesn't work. It allows them to modernize their technology gradually, moving certain workloads to the public cloud while keeping others on premises. A hospital, for example, might keep its sensitive patient records in a secure private cloud to comply with privacy laws, but use a public cloud service for data analytics to discover new medical insights. This hybrid approach allows them to innovate while still maintaining the highest levels of security and compliance. Just when you thought we had it all figured out, there's one more popular strategy we need to discuss: multi-cloud. This is a slightly different concept from hybrid cloud. While hybrid cloud combines public and private clouds, a multi-cloud strategy involves using services from more than one public cloud provider. For example, a company might use Amazon Web Services for its primary computing needs, but use Google Cloud Platform for its specialized machine learning and data analytics tools, and maybe Microsoft Azure for its Office 365 integration. It's about picking and choosing the best services from each provider. Why would a company want to manage relationships with multiple cloud providers? One of the main reasons is to avoid vendor lock-in. Many businesses are wary of becoming too dependent on a single provider. If all of your technology is built on one platform, it can be very difficult and expensive to switch if that provider raises its prices or changes its services. By using a multi-cloud strategy, a company maintains more leverage and flexibility. They can move workloads between clouds to take advantage of the best pricing or features, ensuring they always have options. Another key driver for multi-cloud is to access the best-of-breed services. Each major cloud provider has its own unique strengths. For years, Google Cloud has been recognized as a leader in data analytics, AI, and machine learning. AWS has the widest array of general-purpose infrastructure services. Microsoft Azure has deep integrations with its widely used enterprise software. A multi-cloud strategy allows a company to cherry-pick the absolute best tool for each specific task, rather than being limited to the offerings of a single vendor. It's like having a toolbox with tools from all the best brands. This approach also enhances resilience. While a single cloud provider's region going down is rare, it can happen. If a company's entire operation is running on that one provider, they are at a standstill. By distributing their applications across multiple clouds, they can build a system that is even more resistant to failure. If one provider has a major outage, they can redirect traffic to their applications running on another cloud. This strategy is complex to manage, but for global companies where uptime is critical, multi-cloud offers the ultimate level of flexibility, choice, and disaster recovery. Cloud computing has become the fundamental bedrock of our digital existence. It powers nearly every interaction we have with technology, It's a global network of powerful data centers. When we stream a movie, share a photo, or collaborate on a document, we are using someone else's computer. This has reshaped our world. The cloud provides scalability, cost savings, enhanced security, and robust disaster recovery. These advantages have lowered barriers to innovation. From the public cloud to the private cloud, organizations tailor their infrastructure for security and cost control. The cloud is the present. It is the new normal. Looking ahead, the influence of cloud computing is only set to accelerate, becoming even more deeply woven into the fabric of our society. Consider the rise of artificial intelligence and machine learning. Training a sophisticated AI model requires an astronomical amount of computing power. The cloud makes this possible. Another transformative trend entirely dependent on the cloud is the Internet of Things, or IoT. The cloud is the only platform capable of ingesting, storing, processing, and analyzing this enormous data tidal wave. We are also on the cusp of new computing paradigms like edge computing and serverless computing, both of which are evolutions of the cloud model. Ultimately, the future built on the cloud is one of increased intelligence, connectivity, and automation. The cloud will be the engine driving progress. Now that you understand cloud computing, you might be asking, what does this mean for me? On a personal level, this knowledge empowers you to be a more savvy and secure digital citizen. You can now ask more informed questions about how your data is protected. Professionally, a grasp of cloud concepts is rapidly becoming a vital skill across an astonishing range of careers. Fluency in the language of the cloud will make you a more valuable and effective professional. Furthermore, this understanding opens up a world of opportunities for creation and innovation. With a credit card and a good idea, you can access the same world-class infrastructure that powers major companies. The cloud provides the tools and the platform to turn that idea into a reality with minimal upfront risk. Your role in this cloud-powered world is whatever you choose to make it. You have equipped yourself with a new lens through which to see the world and a new set of tools with which to shape it. Today, we've covered a tremendous amount of ground, from cloud basics to complex strategies. This introduction gives you a strong foundation, but the cloud is vast and constantly evolving. We've opened a door, now continue the journey. Developers and IT professionals should get hands-on with free tiers from AWS, Azure, and Google Cloud. Business leaders, students, and curious individuals can explore countless resources. Don't stop here. Take one concrete step this week to continue your cloud education. The journey of learning is continuous, and in technology, staying curious is your greatest asset. As we conclude, I want to return to the simple, powerful metaphor of the cloud itself. For centuries, humans have looked to the clouds in the sky for meaning. They saw shapes, they predicted the weather, they saw them as symbols of dreams in the heavens. In our modern age, we have a new kind of cloud. It's not in the sky, but it is all around us. It's a man-made creation, a testament to human ingenuity, built from silicon, glass, and lines of code. This digital cloud also holds our dreams, our creations, our communications, and the collective knowledge of our civilization. This new cloud has become the great connector of our time. It bridges distances, collapses time, and links us together in ways that were unimaginable just a generation ago. It allows a student in a small village to access the same educational resources as a student at a top university. It allows a small artisan to sell their crafts to a global marketplace. It allows a family to stay connected through video calls, even when they are separated by oceans. The cloud is a profoundly human technology, one that, at its best, amplifies our ability to learn, to create, and to connect with one another. Of course, like any powerful technology, the cloud presents us with challenges we must navigate thoughtfully. Questions of data privacy, security, environmental impact, and digital equity are critically important. As informed citizens, it is our responsibility to engage in these conversations and help shape a future where the cloud is used responsibly, ethically, and for the benefit of all. Understanding how it works is the first step toward being able to participate meaningfully in that crucial dialogue and ensuring this powerful tool serves humanity's best interests. So, the next time you save a file, stream a song, or join a video call, take a moment to look up at the metaphorical digital sky. See it not as magic, but as a masterpiece of engineering that you now understand. Recognize the incredible network of people, buildings, and machines working in concert to make your digital life possible. The cloud is one of the most significant technological revolutions in human history, and its story is still being written. And now, you are equipped with the knowledge to not only watch that story unfold, but to be an active part of writing its next chapter. Thank you for joining me on this journey. Before you go, let's keep this journey going. If you found this video helpful, hit that like button. It helps more people discover the world of the cloud. Subscribe to our channel for more easy-to-understand guides on the technology shaping your life. Got questions, ideas, or your own cloud story? Drop them in the comments below. We'd love to hear from you. Remember, the digital sky is always evolving, and so can you. Be part of the conversation. Stay curious, stay connected, and thanks for being here.